Okay. 1.5 course practice quiz. This one's, I think, a bit hard. The specific heat capacity of copper is 380 joules per kilograms. فالheat capacity is C of copper. هاي C 380. The temperature of 1 kilogram sample of copper is being raised by a heater marked 2 ampere 12V. So أعطونا الماس وأعطونا الكرنت وأعطونا الفولتج. Okay, I is current. In 300 seconds وأعطونا time. The temperature of the sample will be raised to something. Okay. نحنا, what do we know about C? We know, actually, you know what? Before the temperature, before all that, what do we know? What do we know the formula is? Okay. هني بدنا temperature. What formula do we have that has to do with Q, M, and temperature, whatever, Q, C, M, and T? It's Q equals M, C, delta T. صح? Okay. نحن شو بدنا temperature, right? Okay, let's say, how do you get the temperature? Delta T will be equal to Q over MC. صح? Okay, so we found the equation for delta T. طب ماشي, let's start substituting. Delta T equals, okay, Q. Do we know what Q is? Q is energy, right? And if you go back to our formulas, what did we say we can replace Q with? It should be here. We can replace Q with IVT. It's somewhere here. Somewhere here. Q is equal to IVT. Remember that. It's the product of current, voltage, and time over MC. You can memorize this directly, or I like to keep it as Q because MC delta T, and just remember that Q is equal to IVT. Okay. هلا, I is 2 amperes. V is 12 volts. Time is 300 seconds. Okay. The mass is 1. The C is 380. Can we find delta T? Yes, we can. Let's just put it on a calculator very fast. 2 times 12 times 300 divided by 380. You're gonna get, okay, you're gonna get 18.9. I think they said to the nearest integer. Yeah, to the nearest integer will be 19. Okay, Kelvin. Celsius, it doesn't matter. They're asking how much it will be raised by. So they're asking for delta T. So the unit doesn't matter. Remember, delta T in Celsius and Kelvin is the same. Okay, 50 grams of ice cubes. This one's a bit tricky. 50 grams of ice cubes were immersed into 0.8 kilograms of liquid water at temperature 27 degrees Celsius. Given that the heat capacity of water, specific heat capacity of water is 4.2 times 10 to the 3, and the latent heat of fusion of ice is 3.4 times 10 to the power 5 joules. What is the energy necessary to melt the ice cubes completely? Okay, let's start with part A. نحن, what do we call the energy used to melt? We call it the LF, right? Latent heat of fusion, right? The temperature, the energy needed to melt is latent heat of fusion. How about to boil? Latent heat of vaporization, right? All of these, you need to read the notes, or watch the notes. Watch the notes videos, okay? It's like the book. I'm telling you, it's like the book. Watch first 1.4 to 1.1 to 1.4 from the term 1 week 2 physics CA, and then watch the 1.5 to 1.7, then start solving the quiz and course practice, course revision. Anyway, so it's latent heat of fusion. Okay, how do we find the Q when it's melting? The energy needed, we do M times LF, right? The mass we want times the latent heat of fusion. The mass is 50 grams. Remember, we need it in kilograms. So divide by 1000, you're going to get 0.05 kilograms. Times the latent heat of fusion is going to be over here, 3.4 times 10 to the power 5. And you should get you should get 17,000. So in kilojoules, it's 17 because you just divide by 1,000. Okay. هلا part B. What is the temperature of the resulting liquid? This one is a bit tricky. Why? You need to understand what's happening here. We're adding ice to water. You guys know when you add ice to a liquid, the ice will eventually melt, right? And it will make your drink colder. So أكيد our water here will lose some temperature and it's going to become 21. طب how did we get 21? Here's what happened. Okay, we know that the ice is going to keep on gaining energy until the temperature of the ice is the same temperature of the water. This is what we call thermal equilibrium. Thermal thermal, I'll write it like this. This is something very important to know. Thermal equilibrium. When you mix two substances together, okay, one hot and one cold, the hot one will continue to lose energy to the cold one until they both reach the same temperature. In other words, thermal equilibrium. Okay, what does this mean? Which one's the hottest one here? The hotter one here? It's the water. So the water will lose Q, will lose energy, right? So Q lost. Q lost by water. We know that Q is equal to mc delta T, right? What's the mass of water? It's 0.8. What's the C of water? It's 4.2 times 10 to the power of 3. Do we know delta T? No, we don't. We know delta T is final temperature minus initial temperature, right? So it should be 27 minus... Oh, no, just 27 minus the other temperature. It doesn't matter, final minus initial. Okay, it should be positive, that's why. So 27 minus whatever the other temperature is. That's called TF, right? So this is the Q of that water is losing. Q lost, let's say W for water. This is the energy water lost. ماشي. How about the energy the ice gained? We know أول شيء the ice gained 17 kilojoules, right? So let's say Q gained. Now the energy gained, and this is for ice here. First, it gained 17 kilojoules so it can melt. صح? So 17,000 plus. What else did it gain? هلا it reached, like let's say this is the ice. It went to 0 degrees Celsius. Now it's at water, right? Did we say it finishes at 0 degrees? No. Now it's continuing to gain some energy, right? And now, since it's water, how do we define the gaining of energy for it? It's mc delta T, right? So what is the mass of the ice here? 50 grams. So 0.05 times the C. C, it's water now, so you can just say 4.2 times 10 to the power of 3 times delta T. Delta T, it starts at 0, right? Ice was it was ice at 0 and it finishes at something. So we can, it doesn't matter, since you're starting at 0, you know something minus 0, it's the same as that same thing. Okay, so you can just say temperature final, right? It started at 0, so let's say temperature final, and it started at 0. This is the same as just saying temperature final, because anything minus 0 is the same. So just say temperature final. Okay, so 17,000 plus this. Okay, now Walid, we know how much energy the ice gained. We know how much energy the water lost. What about them? Didn't we say they reached thermal equilibrium? What does equilibrium mean? Equilibrium means the energy lost is equal to the energy gained. So whenever you see these two equations when you're mixing, you're always going to solve like this. Energy lost equals energy gained. You first find energy lost, then you find energy gained, then you equate them to each other. So it's going to be equal to 17,000 plus 0.05 times 4.2 times 10 to the power of 3 TF equals 0.8 times 4.2 times 10 to the power of 3 times 27 minus TF. You can put this in a calculator and just change TF with X, and you should get 20.6, I think, or something like that. Let's see, 17,000 plus 0.05 times 4.2 times 10 to the power of 3 brackets X, close the brackets, then equals 0.8 times 4.2 times 10 to the power of 3 times 27 minus X, close the brackets, shift solve, equal, you get 20.6 to the nearest integer is 21 degrees Celsius. Okay, if you don't have this function on your calculator, you're just gonna have to do it manually, like you're solving an equation. You just start multiplying everything. Okay, you're gonna get 0.05 times 4.2 times 10 to the power of 3. You're gonna get 210 here, so this, you can cancel this, get 210 TF, and then you have 17,000 over here. Okay, then 0.8, see here, 0.8 times 4.2 times 10 to the power of 3 is 3360. So equals 3360, 27 minus TF, right? Okay. Then you distribute this 3360. So you do times 27 90720, and then 3360 times minus TF is minus 3360 TF equals 17000 plus 210 TF. What can we do? We can take this 17,000 here and this here. You're gonna get 3360 TF plus 210 TF equals 90720 minus 17000. So you can solve this over here. 3360 plus 210 is gonna be 3570 TF. This over here on the right is gonna be minus 17000 73720. Then divide by 3570 قصدي 3570. You're gonna get 20.6. Okay, this is, see how much it would help if you just had a calculator that can just solve equations. Unfortunately, and my actual calculator doesn't have this function. I'm using an old calculator. I don't know, I lost my new one. So I have to actually go through all that process. Anyways, question 3. Okay, they give us a graph. Okay, 0.2 kilograms, 12 volts, 2.5 amperes. Okay, the time that elapses before the sample begins to melt. Okay, so we have the temperature increasing. Okay, and this is ice. Okay, we're heating it until, you know, when it becomes flat, that's when it starts melting. Okay, so how long does it take? It takes 140, because 110, 120, 130, 140. Okay, so the time is 140 seconds. The specific heat capacity of ice, so بدنا C تبعت الice, up to 2 significant figures. How do we find the C? C is equal to Q over M delta T, صح? Remember, Q equals MC delta T. Take everything to the other side, it becomes C equals Q over M delta T. Okay, هلا نحن do we have Q? No. بس شو عنا? They asked us to find the time for a reason. They gave us the volts and ampere for a reason. So it's gonna be, instead of Q, what do we write? I VT over M delta T. So it's gonna be 2.5 times 12 times 140 divided by the mass of it, which is 0.2, times delta T. How much was the temperature changed? From negative 10 until 0. So 0 minus 10. Okay, you're gonna get at the end, I think it was, let's actually do it. Let's see. 2.5 times 12 times 140. Okay, divided by, this is 2100. Because 0.2 times 10 is 2. 2100 up to 2 significant figures, it's 2.1 times 10 to the power of 3. Okay, question 4. Again, graphs, يعني. Okay, here they have 200 grams of ice, again being heated, blah 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 blah. Okay, they want to know the energy. We want to يعني drag and drop to compare the energies based on the graph. Here's the way you can do it. Okay, you look at the graph, you see how much time it took. The thing that took the least amount of time, يعني it took the least amount of energy, right? So here, the thing that took the least amount of time is heating it. It starts at ice. It's heating ice from negative 10 or whatever. We're heating ice, okay? It's still ice over here. Okay, here it's melting. Okay, and here it's actually liquid water. You're heating liquid water. Okay, so which one took the least amount of time? It's heating ice, right? So the minimum one is heating ice. Then the thing that took the longest amount of time is obviously melting. So the maximum energy is melting. Okay, how about the one that took the second most amount of time? It's this one here, liquid water. So energy of heating water. Okay, that's how you can do it. If the specific heat capacity of ice is 2.1, then find the power of the heater. Okay, this one's a bit interesting because we haven't really worked with power before. What do we know? So if you realize here, they gave you the specific heat capacity, they gave you C. Okay, and remember, we have in this graph time, we have the temperature, and we have the mass. So even though it might not be given to you directly, we have C, we have the time T, we have the temperature delta T, and we have the mass. Okay, so we know Q equals MC delta T, صح؟ Okay, عندنا الماس which is 0.2. عندنا 0.2 because 200 grams is 0.2 kilo. عندنا C which is 2.1 times 10 to the power of 3. عندنا delta T كمان. Delta T is going from negative 10 to 0, right? We're talking about the ice here. We're not talking about the water. When is it ice? It's ice only in this segment over here. So from negative 10 to 0, that's 0 minus minus 10, that's 10. So delta T is 10. Equals Q. طيب نحن, do we have anything to do with energy over here? Nothing, right? No, nothing. But what do we have? We have time. What did we say Q can be rewritten as? Q can be rewritten as I V T, right? طب وليد, where's your current and voltage? ما حبيبي, they said power. From grade 9, you know that power is equal to IV. So instead of saying IV, you can replace it by PT. Okay? Asan, we all know that energy is equal to power times time. Okay? So that's why instead of Q, we can write IVT or PT. Okay? Because Q is equal to energy. That's what Q means. Q is energy. So Q equals IVT. Instead of IV, you can say P. So P times T. So power times the time. Do we know the time? In Bala, we do. From here, from 0 until here. At the 50 seconds. Okay, what about... yeah, anyway. هلا can we find the power? أكيد we can. Just divide by 50 on both sides. You're gonna get that power is equal to all of this divided by 50, and you're gonna get 84 watts. Yes, 84 watts. Question 5. The boiling point, okay, and consider temperature, time, whatever, 0.1 kilograms of alcohol. The sample is heated by a 50 watt electric heater. Watt is power, okay? Again, it's equal to IV. Okay, the boiling point, so they give us the graph, the boiling point of ethyl alcohol up to 2 significant figures, how much? So how do we know the boiling point? We know this is initially liquid, right? Initially liquid. So whenever it changes, it's going to become, yani, this here will be the boiling point because we started at liquid. What comes after liquid? Gas. So it's going now from liquid to gas. And what point is that? That's the boiling point. The boiling point will be over here. Okay, let's see how much is the temperature over here. In between 80 and 70, which is 75 degrees Celsius. Okay. ماشي. What is the specific heat capacity of ethyl alcohol? بدنا ال C. Okay. How do we find C? Remember, C, I'm not gonna write Q equals MC delta T, then take M and delta T to the other side all the time. خلاص احفظوها. C equals Q over M delta T. It's the same thing as saying Q equals MC delta T. I'm just rearranging the equation. Okay. What do we have? نحن, we have, let's start with the mass. We have 0.1 as the mass. We have delta T. What is delta T? Delta T, we're going from 10 degrees to 75 degrees. So 75 minus 10. Okay, do we have the Q? Okay, we don't. But what do we have? The power. We have IV. What do we know Q can be written as? P times T, or IVT, right? So instead of saying, if we have power, we can just say Q is equal to the power times the time. How much time did this take us? Let's go down over here. Over here. How much is that? 10, 20, 30, 40. No, wait. It's, let me do this one. This is 1, 2, 3, 4, 5 spaces. 350 minus 300 is 50. If it's 50 in between them and 5 spaces, so 50 divided by 5, that means each space is 10. So 310, 320, 330, 340. Okay? So the time is 340 seconds. So we can rewrite the Q as in power times time. The power is 50. The time we said is 340. Then you solve this all, and then up to 2 significant figures, you're going to get it's 2.6. Okay, let's do this. 50 times 340 divided by 6.5, because 0.1 times 75 minus 10 is 65. 65 times 0.1 is 6.5. Anyway, you're gonna get 2615. Okay, and they want scientific notation, so 2.615 times 10 to the power of 3, and they also wanted two significant figures, so 2.6 times 10 to the power of 3. هيدا الكويز ما بده يخلص. How many questions is it? 14. يا الله. After the temperature in a room drops from 25 to 20. Okay, pay attention. From the temperature in the room drops from 25 to 20. Water vapor condenses into liquid. Given that the specific heat of vaporization is 2400 and the specific heat capacity of water is 4.2, find the amount of heat released into the air. Okay. Water vapor condensing into liquid. It's going from gas to liquid. What did we say? What is the energy that causes the change of state? It's the latent heat, in this case of vaporization, right? And we have it's given 2400. ماشي. So how do we find the energy for a certain mass that's condensing? You multiply the mass times the latent heat of vaporization, right? We know this. طيب, what's the mass of it? It's 50 grams for 0.05 times the latent heat of vaporization, 2400. Okay, and you're gonna get 120. Okay, that's the answer. طب Walid, isn't it dropping from 25 to 20 and then they give you the specific heat capacity of water, so aren't you supposed to do M times C times delta T again with the 50 grams of water? Okay, see, I'm not gonna lie to you, and I got the question wrong because that was I was convinced you were supposed to do that. But after I read it for the 5th time, I realized that it's the temperature of the room that's dropping. They didn't say water. They didn't say water, no. They said room. Okay, so pay attention to that. So if they said temperature of water drop, then أكيد you're gonna do M times C times delta T, بعدين تعمل mass of water times the C of water times the delta T of water. Okay, so pay attention to that. They're giving you this heat capacity of water to trick you. And I'm telling you, the regional head of physics loves to play trick questions. Okay, he loves to try and take, only here is just Q equals M times LV. Okay, that's it. Because the only thing happening here is the water vapor condensing into liquid. Question 7. Okay, this is pretty self-explanatory. أكيد. Here it starts as a solid. You have two plateaus. So the first plateau is obviously melting, and the second one is boiling. Okay, here we start with heating a solid, right? I'll change my pen to red. After you heat the solid, what happens to it? It melts. Then what happens after it melts? It becomes liquid. So we're heating the liquid. What happens after it heats the liquid? It boils. I don't know what to say, to be honest. It's pretty easy. Here for question 8, they told us to consider the following information. Okay. The human hair can absorb 20% of its own mass in water. The mass of hair of a typical person is about 0.8, and then we said the latent heat of vaporization of water specifically is 2.2 megajoule per kilogram. The maximum mass of water absorbed by the hair of a typical person is how much? Okay. أول شيء, we have to know that the typical person is 0.8 kilograms. It has 0.8 kilograms of hair, right? And we said, how much is the percentage that the hair will absorb? 20%. So what is 20% of 0.8? 0.16. So the amount of water the hair can absorb is 20% of its mass, so 0.16. Okay, so now we know that the water we absorb is 0.16. The amount of heat due to evaporation as the hair dries. So all the water is on your hair. It's gonna dry now. It's gonna evaporate. How much heat does it need to evaporate? We know Q equals M LV, right? So here it's gonna do the mass of the hair, which is 0.16, times the latent heat of vaporization, which is 2.2 megajoules per kilogram. نحن we're working with kilojoules. So if you want mega is 10 to the power of 6. Kilo is 10 to the power of 3. So the difference between them is 10 to the power of 3. Okay, so you can just multiply this by 10 to the power of 3. Okay, 2.2 times 10 to the power of 3, and you're going to get 352 kilojoules. Okay, question 9. A sample of 70 grams of steel whose specific heat capacity is 385, heat from 20 to 80. What is the quantity of heat needed to raise the temperature here? Here it's a direct application of the formula mc delta T. Okay, so in this case the mass of steel is 0.07. Okay, times the C of steel, which is 385, times delta T, which is 80 minus 20, which is 1000. You should get 1600, but they want it in kilojoules, so it's 1.6 kg. Please, in written part, don't forget your unit and significant figures, please. Okay, the phase change of the sample here occurs in what time interval? Phase change is the flat part where it's both two states at the same time. So where is it two states at the same time? Here, in between 2 and 8. A very, very, very easy question. So the boiling point of mercury is 357 and its latent heat of vaporization is 300. The energy needed to completely change a 0.15 kilogram sample of mercury from liquid into gas at its boiling point 357 is how much? How do we find the energy needed to change a sample at its vaporization? It's MLV. صح? So the mass of it is 0.15. The latent heat of vaporization is 300. So your answer is 45 kilojoules. Always the unit in your answer is the same as the unit you used while solving. Okay, so kilojoule, kilojoule. Question 12, which is true about evaporation? It occurs at any temperature, we know this, and it causes the temperature of the liquid to drop. Okay, at the boiling point, evaporation takes place anywhere within the body of liquid. Akid, since all of them, like let's say you have water, it's all 100 degrees Celsius. شو حيصير لها? they're all gonna start evaporating, right? So it's gonna take place anywhere in the liquid. يلا قربنا نخلص. The energy required to raise the temperature of 1 kilogram of substance by 1 degree Celsius is called what? The specific heat capacity. C. In other words, C. Question 14. Okay, the energy required to turn 1 kilogram from solid into liquid, we said that's latent heat of fusion to melt it. Okay, the energy required to turn 1 kilogram of substance from liquid into gas, قلنا هيدي latent heat of vaporization. Thank you so much for watching and good luck.